All right, this is the last section, as I said, of R7, and we're calling it F. If you notice the title of it, complex rational expressions. Why do you think they say complex? Because it's super hard? Is that why they say complex? That's not really why. It's not really why they say complex. No, I'll tell you. I just figured everybody would think that it's called complex because it's really difficult. Well, no, that's not why they call it complex. It's basically like this. It's basically, I say it like this. It's a fraction divided by another fraction. Okay? So let's start off super easy before we do an example. Super easy. So there's a fraction, right? Now, when you get up to algebra, you quit kind of doing this for division. Would you agree? All right, when you're in elementary school or middle school, you did a lot of this stuff for division. But we show division by a fraction. So you have a fraction being divided by another fraction. Everybody see that? So this right here would be considered a complex expression. All right? I guess you could call it rational. Sure, because it's a fraction. Complex rational expression. It's a fraction being divided by another fraction. Now, how in the world would we work something like this? What would we do to this? Go ahead. You flip. Which one do you flip? The bottom one. That's right. Can't see? Is that what you said? Oh, you said AC. All right, so watch. You take the first one, you keep it the same. Everybody with me? I mean, this is a real basic idea of what we're doing today. All right, so if you can get this, hopefully you should be able to get what we're going to do today. So you take the top. Instead of dividing by the bottom, what do? We multiply by the reciprocal, okay? Or you flip the bottom. So if you flip the bottom, what do you get? D over C. And now you've turned a division problem into a multiplication problem. See how easy that is? And now you just work this thing out. So what would this be? AD over BC. You with me? Yes. All right. So that's just the basic idea of what we're doing. It's going to get a little bit tougher than that, a little more complex than that. But the complex right there, it just means a fraction being divided by another fraction. Okay, that's the only thing. Now, we've done division, we've done fractions. We're going to put a lot of the stuff that we've learned already together. We're going to have to find a common denominator. We're going to add some fractions together, subtract some fractions. We're going to multiply. We're going to divide. We're going to do basically everything that we've learned up to this point in these problems. Okay, and I have 2 examples. And then we'll be done. So first one is, if you look in the book, I think it's example 10. All right, so if you look in the book, it's example 10. So all these problems say to do this. They say to simplify. All right, and that's what we're doing. So here we go. Here's the first one. Write it down. 1/2 plus 3 over x over x plus 3 over 4. Okay? So you see some things that are familiar, right? You see adding fractions with uncommon denominators, right? We've done that, all right? And now you see what we just talked about, a fraction being divided by another fraction. Before I actually do that, multiplied by the reciprocal thing, what I'm going to do is I'm going to simplify the top and I'm going to simplify the bottom. Well, the bottom's already simplified, isn't it? I can't do anything with that, all right? So I'm just going to leave it like that. But I can add those 2 on the top first. That's what I'm going to do first. Before you start multiplying by the reciprocal, simplify the top, simplify the bottom. Then you can flip it and multiply. Everybody with me? Yeah. All right, so there's nothing really new to this. So let's add these together. So I'm taking this and I'm adding those fractions. So what do I need to add fractions together? I need a common what? Denominator. And what would that be in this situation? A 2x, that's right. Okay, we've been doing that recently. Now we asked ourselves, remember this? Every single time we do this, ask ourselves, what did we do to 2? Or what did we multiply 2 by in order to get to 2x? Multiplied it. What? We multiplied 2 by 2 to get 2x? If I multiplied 2 by 2, come on, think of what you're saying. You're just throwing stuff out, okay? If I multiplied 2 by 2, I would get a 4. That's not 4. Okay, so what do I multiply 2 by to get to this? An x. So I multiply the top by x. Now, Gage, you can answer that question. What did I do to x? Gage, you're not even watching now. Now's your big chance. What did I do to x to get 2x? Multiplied it by 2. So I multiply the top by 2. Everybody with me? All right. So what do we get on top now? I get x plus 6. Do you agree? Yeah. So now it's going to make it a little bit easier for us to do the next part. So make sure, again, the key to this, maybe even write it down off to the side or something so you remember. Simplify the top first, then simplify the bottom, and then you can multiply by the reciprocal. So you didn't have to simplify the bottom because it was already simplified. But most of the time, you'll probably have to do something like this to the top and the bottom. All right? So now what do? We keep the top the same. So I'm just going to rewrite the top, or the numerator. And instead of dividing by x plus 3 over 4, we're going to multiply by 4 over x plus 3. Very good. And now we have to simplify this. It looks like you might want to cancel out this x and this x, doesn't it? Yeah. But by the way I asked the question, do you think you're going to do that? No, you're not. Why do you not cancel this x out with this x? That's right, because they're being added to something else. Okay? We talked about this. Watch. If I had this, can I cancel out the 2's? No, you can't, because what is happening to this 2 right here? It's being added. Division and addition are not inverses of each other. They don't cancel each other out. Everybody's getting this, right? Okay.
But can't you cross out the 6 and 3 and then have it be x plus 2 and then x?
Nope. Nope. Because no, you can't cancel out the 6 and the 3 because it's being added to something else. So I'm just trying to think of something. Watch. If I go 2 plus 5 over 3 plus 5. Okay, here's a situation. It's the same situation. There's just all numbers. There's no variables, okay? Can I cancel out the 5's here? Okay, so if you say, listen to me, there's still a lot of talking going on. You're not watching. If I canceled out the 5's right here, what would I be left with? What would my answer be to this? I'm going to put a question mark. It would be 2 over 3, wouldn't it? If I canceled out the 5's. But is that the answer to this? What is the answer to this? It's 7 over what? 8. Is that the same as 2 over 3? No, it's not. Okay? So you cannot cancel out the 5's. Why? Because it's being added, and you're canceling them out by division, right? 5 divided by 5. Well, addition and division don't undo each other. Okay? They don't cancel each other out. Okay? If it was this, if it was 2 times 5 over 3 times 5, can you cancel out the 5's now? Now you can, because this 5 is not being added to the 2 this time. What's happening to it? It's multiplying, okay? So is division, if I cancel these out, I'm dividing them out, right? If I divide them out, if I divide them, is that the opposite of multiplication? Yes, it is. So yes, I can divide them out now, all right, if it's being multiplied. But look right here. Does this x plus 6 and this x plus 3, do either one of those cancel out with each other? No. And the 3 does not go into the 6 here. Why? Because you would be, if it was 6x and it was 3x, sure, the 3 would cancel out, right, with the 6, and you'd have a 2 on the top. But it's not times, it's addition. All right, enough of that. Now, what about this 4 and this 2? Do they cancel out? Kind of, maybe. I'm going to put this. Is that all right if I do this? It didn't really change anything, right? Because this is being multiplied by 4. Okay? And I can do that as well, couldn't I? Right? Because this is being multiplied by 2x. Now look at this. Does this 4 cancel out with the 2? Or do they divide it? Why? Because what is this? That's right. This 4 is being multiplied by this right here. What is this 2 and this x doing to this? It's being multiplied. So do they cancel each other out? Yeah, they do. So 2 goes into 2 what? Once. And 2 goes into 4 what? Twice. Everybody with me? Yeah. Does this x cancel out with this x right here? Well, you look at it and you're like, well, according to what you said, x is being multiplied, so it must cancel out. Why does it still not cancel out? That's right, because the x on the top is being added to something else. Okay? So this x does not cancel out with that x. So let's write what we have. We got a 2. I'm going to write it like this. You okay if I do this? That's not going to mess you up, is it? Right? I just put the 2 on the outside here. It's being multiplied by x plus 6, yeah? And then what do we have here? X times what? X plus 3. Now, you could just keep it just like that. That would be. It's simplified. Nothing cancels out here. Now, if you wanted to, you don't have to, but listen, I'll put an or right there. There's really no reason to do this, but if you did, I'd still mark it right. So you could have written what? 2x plus 12 over what? X squared plus 3x. Now, if you wrote it like this, I'd give you credit for it. It'd be fine. But you don't need to. It'd just be an extra step that would be, it wouldn't be really any use doing that. All right? So I would just keep it just like that. That's the way I would write it. What? Yeah. Well, they're all easy, aren't they? All right. Does that mean you didn't agree with me? All right. So example 11. You ready? And again, it says to simplify. This is the last example that we're going to do, and then I'm going to let you work on the homework, okay? Write this down. Come on, what'd you think? You think it's going to get easier? No, the examples always get a little tougher, right? They start off easy. You got it written down? Okay. Oh, stop. Do you need some paper towels back there? Wipe up all the tears that are on your table. Look at this. What's the first thing we do? We simplify the top, correct? Okay, so forget the bottom right now. Let's just look at this. Let's take a look at this and just simplify this. Why is it not simplified? Because you got to do what to these two things? You got to add those two things together. So what's your denominator right here? It's nothing? It's 1. It's 1. Okay? So I'm going to put my little fraction thing right here, but let's just work the top right now. Then we'll come down to the bottom. We'll do the bottom. Okay? So look at my denominators. You're just adding two things together. And you could kind of look at this as a fraction, right? 2 over 1. All right? So you look at your denominator. This is a really easy denominator. So what if I have this and this? What's my common denominator? X minus 4. Okay? Now, we ask ourselves the age-old question every single time now. What did we do to this to get to this? Yeah, technically you multiplied it by 1, didn't you? So you just multiply the top by 1. You could kind of say we didn't really do anything to it, right? But technically, yeah, you multiplied it by 1. So we just put an x squared right there. And put a plus. Why do we put a plus? Because of that plus right there. And now you ask yourself, what did you do to 1? What did you multiply 1 by in order to get to x minus 4? You multiplied 1 by 1 to get x minus 4? You multiplied 1 by x minus 4 to get to x minus 4, right? So what do you do to the top? Thank you. You multiply the top by x minus 4. Right? You understand that, don't you? Yeah, what'd you do to this to get to this? You'd multiply by x minus 4, so you do the same thing to the top. Tell you what, let's just distribute right now. You okay with that? Instead of writing it down 2 times x minus 4. Yeah, let's distribute. So let's do that. So what do we get here? 2x minus 8. Very good. So we've simplified the top. Yeah. I see something that we might do eventually. Do you see x squared plus 2x minus 8? What do you think? Yeah, we'll probably have to factor it. We'll see. But we'll wait till after we finish the bottom, okay? So let's do the bottom. Now, we could also write 1 over 1. This is kind of the same idea, isn't it? This one right here. So what's my common denominator? It's x. No, it's not x minus 1. You look at this and you look at this. How do I find a common denominator? In this situation, I can just multiply them together, correct? So what's x times 1? It's just x. Okay, so the denominator is not x minus 1. It's just x. Now, what do we do to x to get to x? Times by 1, so we just multiply the top by 1, which is 2x minus 2. Now, what did we do to this? Same thing here. What did we do to 1, or what did we multiply 1 by in order to get x? Multiplied by x. So what do I do to the top? Multiply that by x. So it's what? Minus x. Minus 1x. Okay? All right. Let's do some stuff here. Looks like we can do some more. Does that look familiar? It better look familiar. So trinomial factoring. We've done tons of those. We've probably done, well, I don't know, dozens, but we've probably done at least a dozen or more. Yes, ma'am. Yeah, we're going to do that in the next step. Yep. I'm going to do this in the next step, then I'm going to do this in the next step. Okay, so what do you think I could do with this x squared plus 2x minus 8? I could factor it, correct? All right, so let's do that. Because it possibly could cancel with something. It may not, but it might. So we need to give it a chance, all right, to be able to cancel something on the bottom. All right? So what do? X and x? What multiplies to be negative 8 and adds up to be positive 2? Yeah, 4 and 2. Positive 4, negative 2. That works, doesn't it? Yep, plus 4 minus 2. Yep, that works. So plus 4 minus 2. Multiplies to be negative 8, adds up to be positive 2. So that works. Let's simplify the bottom. What can we do here? 2x minus x is just what? X minus 2, right? It's 2x minus 1x is 1x minus 2. And that's over x. Now, we finally finished simplifying the top and simplifying the bottom. Took us 2 steps to do it, but it's all simplified. But we're not done, though. Now we actually want to do what we just learned today, okay? And that's by dividing fractions. And so we don't really divide fractions, do we? We multiply by the reciprocal. So let's keep the top. Yeah, you're going to flip the bottom. So I'm just going to rewrite the top exactly the way it was. X minus 4. If you want to, you can put that in parentheses just to make it look, I don't know. You don't need to. So multiply by what? We got to flip this. So x over x minus 2. And this is being multiplied by this, so I think it's a good idea to put that in parentheses. Now, do you see anything that can cancel out, simplify? Yeah, wasn't that good that we factored that trinomial? Because if we didn't, we wouldn't be able to see that they cancel each other out. So if you can factor, I would factor it. And you could. So we cancel this with this. What about this x plus 4? Does that cancel with x minus 4? No, because they're not exactly the same thing. Those x's don't cancel. This x doesn't cancel with this. We explained that before. So how do I write my answer? I like to put the single number out in front, okay? You don't have to. You could have put x plus 4 first, then the x on the end. Doesn't matter. It just looks better like this. And then over what? X minus 4. And then that is your answer. That's all there is to it. Really wasn't much new, was it? I mean, it's the same lesson, so you figure it wouldn't be a whole lot different, right? Because it's all R7. But but it's a little bit different. They threw that little bit of a twist of the complex fractions. So really, was this any more complex than anything we've done before? I don't think it was. But the reason they call it complex fractions is because you got a fraction divided by another fraction. All right, here's your homework. It's section R7. What do we call it? D?
No.
What did I call this? D. This is R7D. Again, why did I call the lesson R7F and then I call this thing R7D? Because this is the fourth homework, okay? This is the fourth homework on R7. Okay, and it was the sixth lesson that I actually taught. Is this week going to be like this the rest of the week? Everybody's so talkative. My honors class, first period, they were more talkative today than they've ever been. I was like, what is going on? But it's Monday. You've got the rest of the week. Wait till Thursday to be real talkative, or Friday. Why on Monday? I don't know. I don't get it. All right, there we go. Now look, you got 15 minutes, okay? So this is time to work, all right? This is not time to sit around and talk and wait till the end of class. This is time, listen. This is time to work. So I want you to get your book open. I want you to get some paper out. I want you to write number 73, and then I want you to write the problem and then do the work, okay? So that's what we're doing right now. We are not sitting and taking 15 minutes of free time. That is not what we're doing. You got it? All right, let's get to work.